Welcome to our deep dive into the OSI model's third layer, the network layer. The network layer is responsible for determining the best path for data to travel between different networks. It handles the complex task of ensuring data packets can traverse multiple interconnected networks to reach their intended target. To do this, the layer uses logical addressing, specifically IP addresses, to uniquely identify devices across the global internet. Data is encapsulated into packets and forwarded by routers, which act as the traffic controllers for network data. Encapsulation involves wrapping data with a header containing source and destination IP addresses, enabling routers to make forwarding decisions. Think of it like the postal system. A letter includes addresses, and various sorting offices determine the most efficient route for delivery. Routers read these addresses and direct traffic, preventing congestion and ensuring connectivity between isolated local networks. Routing is the process of selecting the best path across multiple networks, maintaining the integrity of the data stream. Routers continuously examine the destination IP of incoming packets to decide where they should be sent next. Advanced algorithms calculate the most efficient route, adapting to network changes or link failures in real time. When packets exceed the network's maximum transmission unit, the layer breaks them into smaller fragments for transmission. Several protocols define how this layer functions, each serving distinct purposes for networking stability. We use IPv4 and IPv6 as the primary addressing standards, with IPv6 offering a vast expansion in address space. ICMP is essential for network diagnostics, helping us troubleshoot connectivity issues through messages like ping and traceroute. IPsec provides a secure framework for protecting communication, encrypting data at the packet level. Understanding hardware is key to grasping how these logical layers apply to physical infrastructure. Unlike switches that manage traffic within a single network, routers operate across different networks, bridging the gaps between them. Public IPs allow global internet access, while private IPs are reserved for isolated local communication behind a router. To summarize, the network layer is the backbone of logical addressing and routing, ensuring your data correctly reaches its destination. Imagine a data packet leaving your device, hopping across routers in various cities, guided precisely by the destination IP address until it finds its way. Once the packet arrives at the final network, the local hardware identifies the specific receiving device and delivers the data. Let's review the critical components of the network layer we've explored today. The core responsibilities include logical addressing, robust routing path selection, and the seamless forwarding of packets across complex network topologies. Together, these functions ensure that your data reaches the correct destination, no matter how vast or interconnected the network may be. Thanks for watching.